Okay, greetings my fellow engineers. So in this video we're going to do a few small problems related to applying our knowledge that we've learned from previous lessons regarding pointers, pass by value, pass by pointer, etc. Okay, so let's just jump right in and look at our first example here. This example here is showing, it's more of like a tracing problem where what we want to do is we want to look at a couple variables and say, hey, what's the output? What is the output from this example? Okay. My recommendation is if you're like me and you're a visual learner, it's really helpful to draw a picture. Okay. So I think whether you're working on a homework assignment, whether you're just trying to solve a similar problem like this, or you're trying to sketch out a design for how you're going to approach a problem, drawing pictures is a very powerful way to get your head around the problem and break it down in a sequence of smaller steps. So let's go ahead and do this. All right, let's go ahead and draw what this looks like. And I think if you understand how I'm drawing the picture, it becomes then trivial to be able to answer the question. Okay, so we've got two variables here. We have variable A with value 1. Okay, and the type of that variable A is an integer. And then we have another variable B, which is a integer pointer. Okay, minor point, I just want to point it out because I've mentioned it prior, but it's confusing and I think it's worth mentioning again. When I declare an integer pointer, I can have this space here, or I can move that star and say int star space B. It's the same thing. Okay, it's the same thing. So you do see it both ways. All right, kind of confusing. I understand how when you're learning this, that can definitely throw you for a loop and cause all sorts of confusion. Just keep that in mind. That's something that's just kind of helpful to know. All right, that line, that same line, line 2, is saying that B points to A, points to the address of A, to be more specific. Okay, where the address of A, where A is in memory. Okay, star B, that star is the dereference operator. Okay, here the ampersand is the reference operator. Okay, so we got the reference operators as the address, and we have the dereference operator, which is the star. The star when we're not declaring the integer pointer data type. Okay. And what that's saying is that we're going to look at B, and we are going to follow B to the address where B points to. That's what hence the dereference operator. And then we are going to overwrite that value, in this case, with value 2. Okay, hence line number 3 from our example code here. Okay, so then it says, okay, what do we get when we print this out? All right, so A at this point has been overwritten to be value 2. Okay, and we're printing the dereference of B. So once again, we follow B and we go to the value that B points to, which is also 2. Okay, so the answer here is it's going to print 2, 2, right? Again, draw a picture. Okay, especially when you're trying to solve real problems, solve homework assignments, work through these things as they get more complicated, you're going to want to have a picture so you don't make mistakes. Okay. All right, let's do another one. The next example here is a super common mistake for people to make. Right? Very, very common mistake, and it's really worth taking some time to break this problem down and talk about why this does not work. Okay, so let's just take a look at the code. This example here, the goal is to return the largest integer. More specifically, to return a pointer to the largest integer, whether the largest integer is A or B, whatever one's bigger. Okay, that's what this code logic's doing. Again, one minor thing to point out, right, is keep in mind, I could have this asterisk for returning an integer pointer, I can have that star here, or I could move it and say int star space largest. Again, it's the same thing. Okay, it's the same thing. Okay, so let's look at why this is gonna cause a problem, right? So the question is, why is there a runtime error? Okay. Or it could actually be a compile error. It's not necessarily a runtime error, but either way, there's an error. Let's say what is going on here, and how do we, and how to try to understand conceptually why it's a problem. Okay. To understand this, right, we want to take a look at the scope of this variable max. Okay, the scope of that variable. Notice max is declared inside the largest function scope. Okay, it's declared inside the largest function scope. Okay, this here, this is the address. Okay, it's saying give me the address of max. Okay, here's the problem. Max is a local variable. That address is no longer valid the moment that function returns. Okay, it is the memory location is freed the moment the function returns. Okay? So that's why this is going to cause a problem. All right. The way to think of this is if you think of memory, and imagine we're calling this function from main. Okay, and maybe we've got an A and B in main. Okay, maybe A is 5, B is 10. Okay, and then we've got this largest function, okay, which has an A and a B. A and B are passed by value. We are going to make a copy of the original ones. Different memory locations, we're making a copy. Okay, and then max also lives down here. Okay, and max is going to get the largest value, which is 10. Okay, but the problem is, right, if we imagine that we had something where a pointer that was getting the value, like imagine in main somewhere, like in main, if we had the call to the largest function doing something like this. Okay, where we have some pointer in main. Okay, that pointer would get the address. It would point to down here, right, in the largest function scope. However, the moment the function returns, okay, the moment the function returns is all of this stuff is freed. Okay, all of that memory space is freed. Okay, so it's pointing to an invalid memory location. This location that pointer is pointing to is invalid. We can't use it. Okay, or it's a mistake if you're using that. Right? Very, very common error. Let me show you if we actually ran this. I think it's helpful to see some code running and actually look at the error message that would happen if we ran this. I've got here that same code. Okay. And if I went and compiled that, okay, notice I'm getting a warning. I'm getting a warning on line 9. Okay, and the warning says function returns address of local variable. Okay, and specifically the error message is pointing to the fact that we are returning an address of variable max. Okay, here's a common mistake that programmers make when you're new at this. All right, when you're new, you're learning it, is this tendency to not really read the error messages, okay, including warnings. You get a warning, you get an error message, take it seriously. All right, take it seriously. It is telling you what the source of the problem is. Okay? You'll also get better over time about being able to recognize and interpret these messages and kind of what they're getting at, understanding some language, like the fact that it's returning an address of a local variable. What does that mean? Okay, and we were just kind of explaining that a moment ago. It's also giving you the line number, line 9, right? So we come over here, line 9, it's complaining about this here, okay, that we cannot return an address of a local variable. Right? Now, I'm going to ignore how we fix this at the moment. Like, what we could do, you know, well, I mean, we could make it not return a pointer, and we could return the value. That would work. Okay, that's one way to do it. They're all alternatives. There's actually more than one way to fix this. Okay, but the main thing at this point, I just actually want to understand why that's a problem. Okay, and be able to recognize that. Okay, let's move on. Right, let's take a look at another example. Okay, here's another common mistake. We've got a function here called swap. The goal of swap is to take x and y and literally swap the values. Okay, to swap the values. Let me back up a moment, and it's actually a little bit more than swapping the values of x and y, right? Specifically, it's to swap the values that are being passed in, right? If we look here at the main function, okay, in main, we have variables m and n, right? 6 and 10. The goal of this is that by the end of after calling the swap function, we want variable m to have value 10 and variable n to have value 6. However, this example is not going to work. Okay, there's a mistake. There's a mistake. Let's draw it out. Let's talk about why there's a mistake. Okay, and then let's look at how we could fix this. Okay, so first of all, notice that the two parameters going into the swap function are passed by value. Okay, they are passed by value. Okay. Let's draw out what that means. So I'm going to look at our example in memory again, and I'm going to draw it like this, where we have our main. Okay, our main has m and n, okay, and that's going to be 6 and 10 for each one of those. Okay, and then our swap variables in that function scope are going to be x, y, and temp. Okay, temp gets the value. So it's before even, let's just look at how when the function's initially called, we're going to do pass by value, and we are going to have the copy of those values. Okay. Then we get to the first line inside the swap function. Temp gets the value of x, so temp gets 6. Okay. X gets the value of y, becomes 10. Y gets the value of temp, it gets 6. Okay. And then we have a very, very similar problem to what we saw before. Okay, because the problem here is what happens when the function returns. Okay, what happens when the function hits this line here, okay, is that once again, all of this memory here is freed. Okay, so the result of the function is it did nothing, right? When we get to that last line here, right, when we get to the last line, right, the end result is m and n are still the original values. Nothing was swapped, nothing was changed. Okay, so to kind of answer the question where it says, well, what's the result of this code snippet, right? Well, the result is m is still 6, n is still 10. There's no change. So now let's look at how we would actually go about fixing this. How would we go about improving this to get these to be correct? Okay, so you might have guessed this, but the solution is to use pass by pointer. Okay, this solution will work, hint, hint. Okay, but let's explain why. Okay, first thing to notice, let's take a look at the swap function in this case, and I want to point out that unlike the prior example, here we are using x and y are pointers. They are integer pointers. They are not integers like we saw in the prior example. Okay. Let's trace out what's going on here. How is this working? How does this work? Why does this work correctly? Okay. So let's see. I need a little bit of space to write, but I'm going to go ahead. Let me do that down here. To write a little bit smaller this time, but we've got our main function. Okay, we have m and n. We've got our 6 and 10, just like before. Okay, and now in the swap function, okay, we've got our x, y, and our temp. Okay, x and y are now integer pointers. Okay, x is initialized to point to m. Okay, and y is initialized to point to n, if you can see that properly. Okay. Temp gets the value, the dereference of x. Okay, the value that x points to. Notice the dereference operator. Okay, star x. So temp is going to get the dereference. So x points to value 6. So temp is going to get 6. Okay, then we have the line star x equals star y. Dereference x equals the dereference of y. The value x points to and the value that y points to. Okay. In that case, right, we say, okay, the value that y points to is 10. Okay, and we're going to overwrite the value that x points to be that value 10. Okay. Then we get to the last line, star x. The value that y points to is going to get the value of temp. That value is 6. Okay, when the function returns, it doesn't matter that we go ahead and wipe and free all of this space, okay, because the key thing to note is that m and n now have different values. The values were swapped, which is what we wanted. Okay, so that is correct. Okay, if you understand that, you're coming a long way understanding pointers, and you're now seeing how it can be used to solve problems. All right, we're going to continue expanding on it over future lessons too. But before we do that, before we wrap this up, let's go a little bit further. Okay, I'd like to show an example or two that starts to combine some things that we've learned throughout the course. Okay, and so here, if we look at this example is using structures, okay, structures with pass by value. Or we'll do another one in a moment using pass by pointer. Okay, first, let's take a look at the course structure. Okay, notice this structure encapsulates 4 variables. An integer number, okay, and then 3 strings, a name, a professor, and a location. Okay, so the course structure encapsulates all 4 of those pieces of information. All right, so that's important to note that first. Then if we look down and we take a look at the main function scope, we can see that what we're doing is we're initializing a structure, this course structure. We're defining one for this particular course. Okay, we're defining one for the ECE 141. So we've got some things there. Notice we got the dot notation. We're saying we're defining a course, we're giving it a name. That structure, we're giving it a name. An instance of that structure, we're giving it a name, ECE 141. And effectively what we're doing is we're saying we're doing this, right? Where we're saying that something called ECE 141, okay, is going to contain 4 pieces of information. It's going to have a number, okay. Actually, I'll just write it like this, just in the interest of saving space. Okay. It's going to have a number, and the number that was defined was 7864. It was going to have a name of the course, ECE 141, has a professor, Muckle, okay, and then it has a location, and in this case it's ES 140, okay. That's all defined in the main function scope, right? And what we can see here is we call this pass by value function. I literally called the function pass by value function. And what I want to show is that even though this is not a regular simple data type primitive, this is something that we're actually building a aggregate or abstract data type using a structure, it still works the same way. We have this passing in a structure, in this case it's called C, in the local instance in the pass by value function, And notice that what we're doing is we're literally making a copy, just like we would an integer or any other data type that was coming in. So we're going to, by default, this is going to copy all of this information. Okay? If you can read all that. Okay. So it makes a copy of it, right? Although it's a structure, it still does the same thing. We are making a copy, right? When we call it using pass by value. Now, this is kind of a little bit of a silly example what this function is doing, but I literally have it change one thing. I have it change the location to a different room. Okay, it's kind of a dumb example. It's meant to just kind of illustrate a kind of a key point. Okay, notice that if I change the value of that copy, right, because it's passed by value, it's considered much safer, right? It does not impact the original version, the original copy in the main function scope, okay? Because just like our other examples, when we go ahead and we have this function return, okay, this is freed, that memory location, okay, and we have our original data is still preserved, okay? We don't change any of the original data. And that's one of the powerful things about using pass by value is you are protecting the original data. This way you don't call functions and have functions do weird things and change all sorts of data in other places in your program, okay, which would make it very hard to solve and find problems. Right. So we look at the screen output here. Really what I'm indicating here is that when we enter the pass by value function, okay, even though the pass by value function changed the location information, okay, the main function, the structure in the main function remained the same. It was not changed. Okay? And if we use pointers instead, we can go ahead and change it. We're going to have one copy if we're doing pass by pointer. This is a very, very similar example. Okay, I'm changing a couple key things to point out. Okay, for one, notice that the input going into the pass by pointer function is, of course, a pointer to a course structure. Okay? And I think it's worth pointing out, because I might have skipped over it a little bit earlier, but notice that if it's a pointer as the input, okay, down here when we're calling the function, we want to make sure that we are passing in an address to the structure. Okay, this way we are initializing the pointer correctly. Okay, so in this example, right, one thing is we kind of go over and we look at the screen output. Notice that when we changed the location, we changed something in the structure in the pass by value function, we did go ahead and we did change the original value because there's one copy. Okay, so passing in pointers is actually a lot more dangerous than passing in a value, because you can have it impact things that are outside the local function scope of that function. Okay, that's one reason that a lot of times people add the word const, right, for constant before passing in a pointer, saying, hey, you could read that memory location, but you cannot change it, right? That's much safer to do it that way. Okay. All right. Another thing to note, okay, is notice the syntax here of how we were saying star C and then dot whatever field we want. Star C dot number, star C dot name. Okay, we are dereferencing the course pointer, and let's go ahead and draw this out. Right, if I have our course pointer C, okay, that literally points to something in memory that contains all this original stuff. Right, it contains the original number, okay, the name, okay, and the location. And if I want to change any of those values, or read them for that matter, I need to dereference C. Okay, I need to dereference that, and then I can operate on that structure, the values in that structure, and say dot on whatever field I want. Okay, so when it's looking at, like, say, the string copy, and we're overriding the location, we are changing that to ES19. Notice we're changing the original value. We're changing the original value. Okay. So it's important to understand why, right? And understanding the syntax and what it means. Star C, right? Think about the data types, right? The data type here is a course pointer, okay? The data type here is a course, the course structure. I can't use the course pointer data type and say course pointer dot something. I can say course dot something with the dot notation, okay? So I need to dereference. If I dereference the course pointer, then I'm operating on the course. I can go ahead and grab any one of those fields using the dot notation. Okay. This syntax of dereferencing a pointer and then saying dot something is very common, and there's actually two ways to do it. The other alternative way is the example I'm showing here, that instead of saying star C dot whatever, I can use this notation as C arrow and then whatever field I wanted. Okay, that is equivalent to doing that. They are the same thing. Okay, I don't care which one you use, but you should just know the fact that they're identical, right? Because they come up. Sometimes you're looking at somebody else's code, they're using one versus the other. You should understand what they mean. Okay, and then use whatever one you feel like is based on your personal style. Okay, so the code here I'm showing is literally the same thing. It's just using the other style. Okay. All right, that video went a little longer than I anticipated, but I encourage you to once again go back, listen to it multiple times, make sure you really understand it. You know, one of these great things about the videos is you're able to rewind, go back, listen to parts that were confusing multiple times. And then please, you know, this is meant to be, it's, you know, even though it's a recorded video, I encourage people to ask questions, right? We can help you outside of the, you know, outside of our pre-recorded class, right? Myself, great TAs, right? We got a lot of people that can help you out. So if you're stuck and you're confused and you're listening multiple times and you feel like you need to reach out to someone, please, I encourage you to go ahead and do that. Otherwise, stay safe and healthy, and I will see you soon.